In this video, we are going to have a look at cubic and biquadratic equation. In the last lecture, we worked with quadratic equation. Just like a quadratic equation has a degree of 2, a cubic equation has a degree of 3. That is, highest power is 3. So let's say if I write an equation like this, ax cube plus bx square plus cx plus d equals to 0, then it will be a cubic equation. Just like a quadratic equation has two roots, this is going to have three roots, that is alpha, beta and gamma. So that is three roots. Now if I expand this, before expanding this, what I can do is I can write it as a roots or as factors. So if you remember, we discussed that if alpha and beta are the roots of the equation, then alpha minus alpha and x minus beta are factors of that equation. So if alpha, beta and gamma are the roots of this equation can be written as x minus alpha, x minus beta and x minus gamma equals to 0. Now if I expand this, this will be x cube minus alpha plus beta plus gamma x square plus alpha beta plus beta gamma plus gamma alpha, actually not delta but alpha, minus times x minus alpha, okay, here I'm making some mistakes but that is fine, minus alpha beta gamma equals to 0, right? This is the equation. Now if I compare this equation and this equation, I find firstly that this, what I can see is sum of roots taken one at a time, right? And this is sum of roots taken two at a time, right? And this is product of roots, correct? So alpha plus beta plus gamma can be written as minus b by a. Alpha beta plus beta gamma plus gamma alpha can be written as c by a, and alpha beta gamma can be written as minus d by a. These are the three things that we get from this equation, from cubic equation. Just like in quadratic equation we had formulas, here also in cubic equation we have these formulas for sum of roots taken one at a time, sum of roots taken two at a time, and product of roots. Cubic equation has a degree of 3. Biquadratic equation has a degree of 4. So that means a equation like this, ax to the power 4 plus bx cube plus cx square plus dx plus e equals to 0. This could have roots like this, right? And if we write it as factors, we could write it like this. And if you expand this, it would look something like this. Sum of roots taken one at a time, then sum of roots taken two at a time, like this, and sum of roots taken 3 at a time, and at the last, product of the roots. Now you can compare and find out what are you getting. Mostly in CAT you won't see questions on biquadratic, it's limited to cubic itself. Let's do our questions because that is the most important aspect. Let's say you're given an equation x cube minus 18x square plus mx minus 120 equals to 0, and roots of this equation are given in AP, and you need to find m. So try to find that out. Firstly, I hope that you know how an AP works or what is an AP. Whenever a series of numbers have the same difference, then it is called an AP. So let's say I have 3, 6, 9, 12. So here you see 3, difference 3, difference 3. Let's say 5, 12, 17, 22. Here, okay, this is the wrong. Let's take it 7. So here 5, here 5, here 5. This is an AP. If I take 6, 13, 20, 27, 34. So look, difference is 7, difference is 7, difference is 7, difference is 7. This is an AP. Okay, so now let's come back to the question. My roots are given in AP. So I can take it as alpha minus D, alpha and alpha plus D. These are the roots of my equation that I have been given. Now, sum of roots, can I write it like this? Alpha minus D plus alpha plus D. Since these are my three roots, so I will write it like this. And with the formula, it would be minus B by A, that is minus of minus 18 by 1, which is basically 18. Here D will go with D, 3 alpha will be 18, so alpha is 6. So now your roots are actually 6 minus D, 6 and 6 plus D. Let's look at product. Product is going to be alpha minus D, alpha, alpha plus D, and product's formula is minus D by A. So minus 120 on 1. So this is gonna be 120. So 6 minus D, 6, 6 plus D is 120, 20. This is 36 minus D square, A square minus B square, 20. D square is 36 minus 20, that is 16. So D is plus minus 4. So alpha is 6. So other two roots are alpha minus D and alpha plus D. So 6 plus minus 4, 6 plus minus 4. So this would be 2 and 6. Right? Sorry, 2 and 10. So your roots are going to be 2, 6 and 10, and that is your answer. Okay, so you have the roots actually. Now what you could do is you could put any of those values in here. So essentially what you could have done is you could have alpha over here and it was solved here only. You could have just put alpha x equals to 6 here and you could have satisfied the equation and you could have gotten m. But the thing is, most of the times you will have two variables inside this. So that is why it is good to know all of this. Okay, so now just put alpha equals to 6 or x equals to 6 in this equation. So you will have only one variable, that is m, and you will find it out. I will just tell you what it is going to be. M is going to be 92. So you can try it, solve it, and see if you're getting 92 or not. Let's see another question. If PQR are the roots of the equation x cube minus 2x square plus 3x minus 2 equals to 0, then find 1 upon p square plus 1 upon q square plus 1 upon r square. This is something that you need to find. Can I write this as p square q square r square, q square r square plus p square r square plus p square q square? So that is correct. No issue with that. Now look, I have the equation x cube minus 2x square plus 3x minus 2 equals to 0. This is the equation. The roots are p, q, r. Sum of the roots, p plus q plus r minus v by a. So that is minus 2 by 1, that is 2. PQ plus QR plus RP is going to be 3 and PQR is going to be 2. Correct? Now let's square this. So PQ plus QR plus RP whole square is going to be 3 square. So this can be written as P square Q square plus, okay, I can write it like this also. Yeah, this is fine. R square P square plus 2 times of PQ multiplied by QR plus QR multiplied by RP plus RP multiplied by PQ. If you remember in the very first lecture, I told you that the A plus B plus C whole square is A square plus B square plus C square plus 2 times of AB, BC and CA. And that is exactly what I have done. Just use that simple formula, simple identity. Now, this is obviously equals to 9 because it is equals to 3 square. So it is 9. This, if you see, this is exactly same as this, which we need to find. So this is K plus 2 times of, let's take PQR common from all these three. We will have remained P plus Q plus R inside. K plus 2 times of PQR is 2. P plus Q plus R is 2. This is 9. So K is 1. 9 minus 8, 1. So this is 1. So that means my numerator is 1. And what is denominator? It is square of this product of roots. So 2 is square. So this is 1 upon 4. And that is your answer. Correct? Now let's see another question. Okay, before we move on to questions, actually, let's see nature of roots. But this time, not for quadratic, but for cubic equations. So nature of roots of cubic equation. But you may ask that, Rupam, in that quadratic equation, we were having discriminant. So we could find with the help of b square minus 4ac, we could find that whether it is real, imaginary, if it is real, that whether the roots are equal or different. So here also we have a similar thing. Look, if I have this equation ax cube plus bx square plus cx plus d equals to 0, okay, if this is the equation, first thing is all my roots could be real. First case. Second case is one real and two imaginary roots. Just this. Just two cases. Now again you might ask, sir, can't we have two real and one imaginary? No, it is not possible. Because if you remember in the last lecture when we discussed with quadratic equation, I told you that imaginary roots always exist in pairs. So if you have one root as this alpha plus I beta, then you have to have your second root as alpha minus I beta or vice versa. So they will always exist in pairs. That is why you all either have all three real roots or you have one real and two imaginary roots. What are the condition? Because in quadratic equation you had discriminant, so you could find whether d is equals to 0, greater than 0, less than 0. Here you have b square. If it is greater than equal to 2ac, then roots are real. But if b square is less than 2ac, then you have one real and two imaginary roots. Gotcha? Now, let's see some examples and it will be much more clear to you. So let's say you are given this equation x cube plus 5x square plus 25x plus 125 equals to 0. Now we need to find whether the roots will be real or all three will be real or one real and two imaginary. So here a is 1, b is 5, c is 25, d is 125, right? So b square is 5 square, that is 25, and 2ac will be 2 multiplied by 1 multiplied by 25, that is 50. So clearly b square is less than 2ac, which means one real and two imaginary roots. One real and two imaginary roots. Okay. So this is about it. Before we move further, I'm telling you two very important properties, so just remember them. Okay, just remember them as it is. First is every equation of an even degree, that is, highest power is 2, 4, 6, 8, 10, and so on, with coefficient. I hope you know what is coefficient. So like in this equation, if you see, this is having coefficient of 1, this is having coefficient of 5, this is having coefficient of 25. Okay, with coefficient of the highest degree term positive and constant term negative will have at least two real roots. So just remember it by heart. So let's say if I have an equation like this, x to the power 4 plus 2x cube plus 5x square minus 6x minus 7 equals to 0. In this, if you check highest degree term positive, yes, this is positive. Constant term negative, yes, constant term is negative. Now since these both are true, this will have at least two real roots. Now since this is of degree 4, so it will have 4 roots. But we know that at least two real will be there. Other two could be real or imaginary, I don't know. But one thing that I know for sure is that two real roots will be there. That is one thing that I know for sure. Similarly, you have one more property, and that is any equation with sum of all its coefficients equal to 0 will have 1 as one of its roots. So let me show you an example for this as well. Let's say if you have equation x square minus 5x plus 4 equals to 0. Let's say this is the equation, okay? In this, if you look at coefficient, this is 1, this is minus 5, this is plus 4, which is sum is 0. Right? So if sum of all coefficient is equal to 0, 1 will be one of its roots. So this will have two roots. Let's call them alpha and beta. One of them is going to be 1. Another could be anything. I don't know. But one of them is definitely 1. Let's see last question for today. Graph of 4x square minus 11x plus 83 will cut x-axis at how many points? I told you, if you remember, in quadratic equation, that if you draw a graph of a quadratic equation, that is a parabola, then in that case, if d is equals to 0, then it has two real and equal roots. That is, it touches the x-axis at one point. Second, if d, that is discriminant, is greater than 0, it cuts the x-axis at 2 points. But if discriminant is less than 0, then it does not cut the x-axis at any point, and it goes like this. It has two imaginary roots only. So we need to find d, that is b square minus 4ac, which is 11 square minus 4 multiplied by 4 multiplied by 83. So this is 121 minus 16 multiplied by 83. Clearly this is greater than 121. So this would be less than 0. So D is less than 0. If this is less than 0, then it will be this graph. So it will not cut x-axis at any point. So the answer is 0 points. This is it for this lecture. I will see you in the next lecture of algebra.